2.4 starts us off talking about, okay, what happens if when I am doing my problem, instead of just having 2 sets in my Venn diagram, what if I have 3? Can I still do stuff with 3 sets? And the answer is yes, you can actually do Venn diagrams for even more sets. It gets really complicated with 5 or 6, but 4 wouldn't be too bad, but we're not going to do that at all in this class. We're going to stop at 3. We're going to let the good times stop there. Okay, so what we're going to do first, just as an exercise to make sure we understand what all the new regions here are communicating, we're just going to take this universe and these sets, and we're going to make a picture out of them. So I'm going to get started with my first example. And so when I label this set, this is, of course, is the universe. We know that from the two, when we have 2 sets. And just so that we're all doing the same thing, because I want it to be nice and easy for you and me to check our answers, we're going to call this set A, this set B, and this one down here set C. That's completely arbitrary. When you're taking your test, if you label the different circles, the different sets, that's fine. Okay, it's not going to affect your answer. But I just want us all doing the same thing. And so what we're going to do is we're going to go through the universe, and we're just going to see where the different values are. So I'm going to start with the number 1. Okay, so number 1, I noticed that the number 1 is in set A, the number 1 is in set C. So it's shared by set A and set C. Now, is the number 1 in B? No, it is not. So here is where set A and C overlap, this eyeball right here that I'm tracing. And I notice there's 2 sections of it. There's a section on the left of that eyeball and a section on the right. Where am I going to put the number 1? You're going to put it on the left. Why did you choose the left? Because it doesn't include C. Well said. I appreciate you interacting with me and saying that. So I put the number 1 here instead of in the center because it doesn't include set B, because the number 1 is not in set B. Does that seem reasonable? Okay, let me know if it doesn't. Okay, I don't want this to be any more complicated than what we've talked about. The number 2 is only in B. So here's my circle B. Where is the number 2 going to be? In the big part, yeah, exactly. 2 is only in B. It's not in A, it's not in C, so it shouldn't interact with those circles at all. I'm going to do a couple more with you, and then I'm going to not bore you anymore listening to me talking about it. The number 3. The number 3 is only in C. And so again, here's my big circle C. The number 3 is going to go out here in this part. Now you might have written your number 3 over more toward the left or something. That's fine. It doesn't matter where its position in that region is, just as long as it's in the big region. My last one before I give you about a minute or 90 seconds to finish is the number 4. The number 4 I see is in all of the sets, A, B, and C. So where's the number 4 going to go on my picture? Right there in the middle. Yeah, in that triangle looking thing. So I'm going to put the 4 right there. So finish out 5 through 15 for me. I'll give you a minute or 2 to do that. All right, so I'm going to start cruising along. Since we all have our sets in the same place, as you're going, check what your answer is with mine. If you've got something in a different place, let's talk about it. It's possible I could be wrong too. So the number 5 I see is only in B. So I'm going to put it right here. The number 6 is not in any of those. So I'm going to put 6 in the box. 7 is also not in any of those. So I'm going to put 7 in the box here. 8 is in A and C. So not in B, so I'll put 8 right there. 9 is in all 3. 10 is in A and B, but not in C. So here's where A and B overlap. I'm going to put the number 10 right here. 11 is only in C. 12 is only in A. 13 is only in B. And 14 and 15 are not in any of those, so I'll put 14 and 15 in the box. Anybody have a question about that? Please ask, because the whole essence of this section is understanding what the different regions are communicating to us. Okay, so if you can understand why the 8 goes where it goes in relation to those sets, then you're doing great. You're exactly where I need you to be. Okay, I'm not seeing any questions, so I'm going to move on because I don't want you to fall asleep on me. So you're going to do the same thing with these Disney movies. Okay, so I'm going to give you like 2 minutes. Take the Disney movies. I'm going to abbreviate because I can't write that small. So put the various Disney movies. Again, let me just define. This is arbitrary, but I want us all to be doing the same thing. A and B are going to be at the top. C is going to be the set at the bottom. All right, again, I'm going to get started. If you're still working, keep working. I'll pause at the end so you can check your answers. So just going to start with my universe. The first movie is Bambi. I see that Bambi is in A and B and C. So Bambi, abbreviated BAM, is just going to be right there in the middle. And my brain has a harder time keeping track of the words than the numbers. So I'm going to cross out Bambi in each of the set so I can see what's going on. Cinderella is next. Cinderella is not in any of those, so I'm going to put Cinderella out here. Dumbo, again, Dumbo is not in any of those, so we're going to put Dumbo out here in the box. Frozen, Frozen I see is only in C, so I'll put Frozen out here. After Frozen comes Hercules. Hercules is in A and B, but it's not in C. So this part is where A and B overlap. The part of this eyeball that is not in C is right here. So I'm going to put Hercules right there. After Hercules comes Mulan. Mulan is only in B, so we'll put Mulan out here in the only B part. Does everyone see what I'm doing? Okay, thank you. I don't want anybody confused. I want to be able to put one of these on the test and have you be thankful that it's there. The next one's Pinocchio. Pinocchio is only in A and C, but not in B, so we'll put Pinocchio right here. And then we're approaching the finish line, Ratatouille. Ratatouille is in B and C, but not in A. Tarzan is only in A. And then that leaves us with Up. Up is not in any of those, so we'll put it out there. Does anyone have one of those movies in a different place that we need to talk about before we move on? All right, now, just to make sure, again, the essence of learning is making sure you can see things from different perspectives. So exercise 2 just does the reverse. It gives you a Venn diagram that's already filled in and asks you to identify different parts of it. So do those 4 things, A, B, C, and D, that are right next to exercise 2, and answer from that Venn diagram. All right, so humor me. This is just helping us review. B with the apostrophe, that's B complement. So once again, what does the complement mean? Yep, everything that's not. So I'm just going to cover up B. And so everything that is not is 1, 2, 9, 10, 11, and 13. There's nothing else that is not in B. So it is 1, 2, 9, 10, 11, 13. Anybody get something different that we need to talk about? The next one is B intersect C. Again, I'm sure you know the answer to this. I'm just helping. The more times you answer these questions, the more it reinforces it in your brain and you make those neural pathways and all that good stuff. The intersection means what with my 2 sets? Where they cross. So B is the pink circle, C is the black circle, and where those 2 circles, I don't care about the blue one, A is not involved in this problem, and where those 2 things overlap is 4 and 5 and 6 and 8. Once again, does anybody have something different that we need to talk about? Okay, let me know, speak your piece. A union C, the union means I do what with the 2 sets? Yeah, good hand gestures. Everything that's in both of them, perfect. You're merging them together. So A is the blue circle, C is the black one. I'm just going to try my best to get this all in number order. So we've got 1, and then I see a 3 and 4 and 5, 6, 8, 9, 10, and 11. Did I omit anything? It's quite possible. I think I got everything there. There's my union. So the last one is A union B. So you can see A union B is everything in the blue and everything in the pink circle. But now I'm combining that with the complement. So what is everything that is not in the A union B pair of circles? 2, 11, and 13. Yeah, I'm just going to cover up the blue and the pink circles, and you can see them right there. 2, 11, and 13. Excellent. So those exercises we've just done, the whole point to them is just to make sure that you feel pretty comfortable with what the different regions mean. So now we're going to take that knowledge and we're going to apply it in a new way. You're going to do something that's a little bit higher order here, and so it's good. So the next thing we're going to do, I've got 2 examples of it, you've got 2 examples, and then we're done with section 2.4. Now what we're going to do is we are going to determine whether this relationship right here, A intersect B complement, is equal to A complement union B complement for all sets. So what I'm not asking for you to make up a couple sets and to see, because in all honesty, for almost every relationship, you could make up two sets and accidentally find a couple that would work. I want to know, no matter what elements I have in what regions of this Venn diagram, is this relationship always true or not always true? So we need a way to do this. And the process is just going to be, can you identify what the different regions mean? That's the whole process. So here's what we're going to do. When we only have two sets involved, I'm going to show you the label. These are the labelings we use for our Venn diagram. I'm going to let A be on the left, B be on the right, just alphabetical order. Now, instead of placing elements in here, what I'm going to do is I'm just going to give each region a name. Okay? So I'm going to call this stuff out here that's A only. Anything that's in A only, I'm just going to, our book uses Roman numerals, so I'm just using Roman numerals. Okay? If you want to use other labels, your conclusions will come out the same. The reason our book uses Roman numerals is so that you don't confuse it with like the numbers that are up here and think they're elements. Okay? So I'm gonna label anything in this region, anything that's A only, I'm gonna say is in region 1. Then anything in the intersection, anything that's overlap, I'm gonna describe that region as region 2. Anything that would be in B only is going to be region 3. And then last but not least, anything that's not in either of those sets that's out here along the periphery, I'm going to call region 4. Now, if you don't know anything about Roman numerals, here's really all you have to know for this class is that a line means 1, a V means 5. And if you put the 1 before the 5, that means to subtract. I before V means 4. If you'd like to learn more about Roman numerals, we just talked about them in MGF 1107. Take that with me some semester. It's a fun class if you need to get another math credit in. All right, so here's how we determine if this is true for all sets. I'm just going to draw a little T with my bar under the equal sign. And what we're going to do for what's on the left and what we're going to do for what's on the right is we're going to determine what region describes this expression right here. What region or what regions describes what's on the left? So here we go. A intersect B complement. I'm going to start off with A intersect B. Now, if you can do this all at once, more power to you, that's fine. So A intersect B. What region or regions represent the elements that would be in A intersect B? Number 2. Yep. That's all the stuff. So any elements, A, B, C, D, E, F, G, H, I, J, whatever the elements of your sets are, any of them that are in region 2 are in the intersection. Great. Okay, now that I know that, you've already told me twice today at least that the complement is everything else. So what regions represent everything else other than 2? Perfect. 1, 3, and then I didn't leave myself enough room, so I'll just put it down here, 4. So that's what I got for the left. And now what I would like you to do is I'd like you to give your best shot, because this is a difficult thing to do and you're learning it. So I want to give you as much experience as we can. So on the right, I want you to determine what region or regions represent A complement union B complement. And my little hint to you is first figure out what region or regions are A complement and what region or regions are B complement. That way you can figure out the union of those two things. I'll give you a minute or two to do that. All right, so let's see how you did. A complement means everything outside of A, so I'm going to cover up A. And so that means any elements that you would have that are in region 3 or region 4 would be the complement. So region 3, 1, 2, 3, or region 4, 1, 5. Then the complement of B is everything that's not in B. So when I cover up B, that means 1 and 4. And now what I'm going to do is I'm going to do the union of those two things. So I have A complement, union B complement. You've told me before a couple times, the union is what you get when you smush everything together. So when I smush all these regions together, I've got region 1, I've got region 3, and I've got region 4. So now let's look at the results. The regions that represent the left and the regions that represent the right. Are those the same, or is there any difference between them? They're the same. Yeah, 1, 3, and 4. 1, 3, and 4. So because they are identical, what we can say is that this is always true. These two things are always equal no matter what sets you bring to the table. If How come 2's not in there? Yeah. On which side? On the left or the right? On the right side. So why is 2 not there? Okay, let's go back through this. So for A complement is everything outside of A. Is region 2 outside of A? Region 2, here's set A. I'm gonna circle it blue. Yeah, region 2 is part of set A. Okay, so that's why region 2 is not part of A complement. The A union? Okay, so we know that any elements that are in A complement are going to be in 3 and 4. Any elements in B complement are 1 and 4. And so now when I do the union, I'm doing the union of these two things right here. These are the results for A complement and B complement. And so I don't have a 2 in either of those. So when I smush everything together that I have, there's no 2 in here to put into the union. That's why it's not included. Okay, great question. I want to get clarity. This is difficult. So questions mean you're learning, and it means you're clearing up stuff. So I love it. Thank you very much for asking that. So we see that the two sets of regions that are my answer are exactly the same. So this is always true no matter what. If there was any difference at all between these two things, it would be not always true. So what I would like you to do, the next problem is super similar to what we just did, very minor change, just because you're going to run through it. So I'm going to leave this picture right here. Do the same thing for exercise 3. Is A union B complement always going to be equal to A complement intersect B complement? Now, if you need to, I'm gonna do every step, but many of you are probably able to do the left side in one step. What's the complement? What's the stuff that's outside of A union B? But just in case you're not there yet, because there's nothing wrong if you're not, A union B, what regions comprise A union B? Well, that is 1, 2, and 3. Those are the things that when I glue them together, I get everything in A and B. So 1, 2, and 3. So then the complement is everything else. So I've got A union B, the complement. What is everything else from 1, 2, and 3? That's region 4. And again, many of you already visualized that and could see it. I know we all learn at different paces, and there's nothing wrong with that at all. So A complement and B complement, I'm just going to get those from the previous problem we just did. A complement, when I cover up A, that leaves me region 3 and region 4. B complement, when I cover up region B, that leaves me 1 and 4. And this time, instead of the union like the previous problem, this time I'm intersecting those. I want to know what region or regions do those two things have in common. And what do those two things have in common? 4. It's right here. You can see it. 4 right there, 4 right there. So once again, I've got the exact same thing on both sides. And so again, my conclusion is that this relationship is always true. We each got one more problem for the day. You're doing great. You're almost to the finish line. You're almost to the long weekend. It's good news. So the other thing is, okay, we've done this with 2 sets. Now we're going to do it with 3. I'm going to show you how the book labels things so that when you do your homework, you know exactly what's going on. So the book is going to label this Venn diagram in the following way. Your universe is outside here. And then the regions are going to get labeled, oh, sorry, I've got A, I've got B, I've got C. And then the regions are going to be labeled like this. This region right here, that's A only, is 1. This region that is A and B but not in C, that's 2. The region B only is 3. This little part of the eyeball down here of A and C is 4. The middle is 5, a V. The part here of B and C but not in A is 6, so I put a V and then an I. So the Romans' twist on this system of numeration was that if a smaller one comes before, you subtract. If a smaller one comes after, you add. So that was their contribution to number systems. And then other people built on that. So again, 1107, it's fascinating. We'll talk about it. This part here, that's C only, is 7, so VII. And then last but not least, and this is all the Roman numbers that you ever have to worry about if you're not going to take 1107 or watch the Super Bowl, is VIII, that's 8. The only time we use Roman numerals anymore are Super Bowls and then copyrights for movies and TV shows a lot of times. I don't know why, that's just the way it is. Okay, so given that, now we're going to do the same thing just with 3 sets. So I've got to be careful. So I want to know if this relationship up top is going to be always true or not always true. So you're going to help me. We're just going to take this one step at a time together. Here's what I would like you to do. I would like you to write down what regions make up set A. What regions make up set A in that diagram? And what did you write down? Here's my circle A. What regions, when I glue them together, give me set A? 1, 2, 4, and 5. 1, 2, 4, 5. Great job. Now what I would like you to do, so we've got set A, we just did that. Now what I want you to do is tell me what regions make up B intersect C. And what did you write down for the regions that make up B intersect C? Okay, 5 and 6, great job. It sounds like you're doing really good. And so then the last thing now is I'm going to take A that we just defined and B intersect C that we just defined, and we're going to combine those with a union. So I'm just going to put a union right here. So now go ahead and combine those with a union, and then we'll compare notes in a moment. So the union means you take everything that you see. So everything that I see here is I've got region 1 listed, I've got region 2 listed, I've got region 4 listed, 5 is listed twice, but remember, we only have to list things once in the union, and then I've got 6. So I'm going to put 6 right here. So I've got 1, 2, 4, 5, 6. We're going to do the same thing on the right side, and we're just going to go step by step. You're going to help me. First thing we're going to do is I want you to write down what regions are A union B. That's going to be there's going to be a couple extra ones there. A union B. And so what did you write down? Here's circle A, here's circle B. What regions make up those circles? 1, what did you say? I'm sorry, I didn't hear you. 1 through 6, okay. I thought you said 1, 3, 6, and I was trying to figure out simultaneously how you got that so I could explain why not. But 1 through 6 is perfect, thank you. So 1, and then 2, and then 3, and then 4, 5, 6. Fantastic work. So do the same thing for A union C. Maybe you already did it, but I'll give you another 30 seconds or so to write down the regions for A union C. And so what regions are A union C? Right, these ones right here, 1 and 2 and 4 and 5 and 6 and 7. So let me write that down, 1 and 2 and 4 and 5 and 6 and 7. Great job. And so then what we're asked to do is we're asked to now take those two things that we just defined and intersect them. So I'm going to put an intersect sign here. So the things they have in common, I notice they both have a 1 in common. I notice they both have a 2 in common. They don't both have a 3. They both have a 4 in common. And then both have a 5 in common as well. They don't both have a 6. Oh, no, they do both have a 6. Sorry. I got old man eyes. I can barely see. They don't both have 7. All right, so after all is said and done now, do I have the same list of regions on the left and on the right? Yes, so that's always true. All right, there's one more. We've got just enough time. What I'm going to do is I'm going to give you, we've got 11 minutes left in our, no, 9 minutes left in our time together. I'm going to give you 5 of it to go ahead and make as much progress as you can on the next one. And then I'm going to help you out. All right, just because I strive to always let you out on time and not keep you over, I'm going to get started. Check your regions with my regions. So the first one is A complement. So I'm going to cover up A up here, and I see that the complement of that is 3 and 6 and 7 and 8. And then I see that B union C. B union C is everything in B and everything in C. So that's going to be 2 and 3, and then 4, 5, 6. And finally 7. So what I'm going to do on the left now, I've got A complement, I've got B union C. So I'm going to now intersect those two things, and this is going to give me my final result on the left side. So the things they have in common, I see they both have a region 3 right here. I see they both have a region 6, and they both have a region 7. So if what's on the right is exactly that, then we know this is always true. If what's on the right differs in any way, shape, or form, it's not always true. Now, on the other side, we start with B intersect C complement. Now, if you can do this all in one step, I know many of you, if not all of you can say, oh, B intersect C is here, and you can cover it up, and the complement is just what's left. But if you can't do that, then B intersect C is 5 and 6. So then everything else is 1, 2, 3, 4, not 5, not 6, 7, and 8. From the previous problem, we saw that set A, and you can still see it in the picture, was 1 and 2 and 4 and 5. So that is set A. And so then the last thing is, now that I've got set A, now that I've got B intersect C complement, I'm going to union those two things together. And let's see what we got. So I'm going to slide down so everybody can see we're unioning these two things together, B intersect C complement and A. Union means take everything. So I've got region 1. Well, I'm going to pause right now. You can already see that it's not always true. Okay, because we've got something different. I'm going to finish the problem just because I'm curious now. So when I union, I've also got a 2. I've also got a 3. Both of them have 4. I've got a 5, a 7, and an 8. So those are clearly different. So this is not always true. Now, before you leave, what I said by sometimes you can make these look like they're true. Well, you can see that in both of them, they have region 3 and they have region 7. So if you just happened to make 3 sets that focused on region 3 and region 7, you could accidentally make up sets that would make this look true. Okay, so that's why we do this general process.